We talked about finding products and quotients in cosine I sine form in class the other day, but I did just want to put up another example in case people need to see it. Very straightforward, works mostly because of trig identities that we've worked with earlier in the year. Certainly you can go back in the book and you can look at some of those examples. But what it comes down to is this. If you've written something in cosine I sine form, if you want to multiply complex numbers, all you've got to do is multiply the moduluses or the absolute values. So in this particular case, that would be 15. Okay? The angle measures are going to get added, okay? This is at a pi over 3 radian measure. Of course, that's 60 degrees. This one also is at a pi over 3, also at 60 degrees. So you're going to add those two angle measures. So it's going to be cosine of, if you add the two angles here, it's going to be 2 pi over 3, or 120 degrees, plus I sine of 2 pi over 3, okay? The angle measures in those positions should be the same, all right? Second example here, division, really just the reverse. You're basically going to, instead of multiplying your leading coefficients, your moduluses, you're going to divide your moduluses. So 12 divided by 3 is 4. Okay? Instead of adding your angle measures, you're going to subtract your angle measures. So we're going to take 5 pi over 6 and we're going to subtract pi over 6. So that's going to be cosine of, that's 5 pi over 6 minus 1/6 pi basically. That would be 4 pi over 6, which is the same thing as 2 pi over 3. Okay? And then plus I sine 2 pi over 3. Okay, so can be pretty simple, can be pretty straightforward if you know how to work with it. Now, the follow-up here, you may not be given values in cosine I sine form, and you may have to convert to cosine I sine form. So in a third example here, let's take a look at one that isn't in that form. I've got it written down off camera here. Let's say I've got something like negative 4 radical 3 plus 4i, and I want to multiply that by 2 plus 2i radical 3. Now, you could FOIL that out. I'm not saying this is faster. I'm just saying it's an option. All right? But you can convert this to cosine I sine form. All right? So to do this, we can kind of think about what this graph would look like. Negative 4 radical 3 plus 4i. Okay? That's going to give you a point basically about right here. All right? That's negative 4 radical 3, you're going back 4 radical 3, you're going up 4, okay? You know, it doesn't have to be angles that you can recognize, but in this case it's a 30, 60, 90 triangle. That's your 30-degree angle. Make sure you're not using your reference angle. Make sure you're using the actual angle. This is a 150-degree angle or 5 pi over 6 if you're writing this in radian form. The magnitude there, the modulus, is 8. So this is the same thing as 8 cosine of 5 pi over 6 plus I sine of 5 pi over 6. Okay? Now let's take a look at the second one. The second one I think is going to be over in the first quadrant. It's 2 plus 2i radical 3. So that's going to be a point here. You got a little triangle, you're going over 2, you're going up 2 radical 3. Your point is going to be right here. Okay, that's a 60-degree angle, or pi over 3 radians, if you want to think about it that way. The absolute value there is going to be 4. Okay, so that number is 4 cosine of pi over 3 plus I sine of pi over 3. And then to multiply these together, you're going to do the same thing that we did earlier. And you know, you could convert it back to kind of standard rectangular form if you need to. So 8 times 4 is 32. You're going to add the angles. Okay, that's 2/6. That's 5/6. That's going to end up being 7/6 when you add those two angles. So that's going to be cosine of 7 pi over 6 plus I sine of 7 pi over 6. Okay, that's a 210-degree angle. And of course, if you did need to convert it back, and it just depends on the form you're working with, you certainly could convert it back. 210 degrees, that's going to be down here in this quadrant, the third quadrant. You've got an absolute value of 32. That's going to be a 30-degree angle there. So you're going to end up going down 16, and you're going to go back negative 16 radical 3 if you look at that. So Remember, you've got a real value along the x-axis, and that would be negative 16 radical 3 plus, actually in this case it would be minus, it's going to be minus 16i would be the result there. So anyway, not saying this is faster necessarily, but just you need to be able to convert back and forth between forms, and that's how it would work in this case.